Good morning, all of you. Hope you are doing good. Now, as you know, we have been discussing our third chapter more about numbers. And today, on this chapter, we are going to discuss a new topic which is prime factorization. So, let's understand what is prime factorization. Before understanding what is prime factorization, we are going to check what is actually mean by factorization. Okay, so let's check it by considering an example. Suppose I am taking a number 12, and you know that this 12 can be written as a product or a multiplication, just like 3 into 4. The 12 can be written as a multiple in different other ways also. Here we just considering 3 into 4. And you know that 3 comma 4. Here the 3 comma 4 are called factors. 3 comma 4 are called factors. So I just expressed this 12 as a product of its factors, or I can say I am just expressing a number in terms of its factors. Okay, whenever we express a number in terms of its factors, then that process is called factorization. That process is called factorization. So what is actually mean by factorization? Factorization is the representation or expressing a number in terms of its factors. Okay, so here we can say that 3 and 4 are the factors of 12, and 3 into 4, it is a factorization for 12. Clear? You can do factorization for 12 in some other ways also. You can write 1 into 12, it is factorization. 2 into 6, that also factorization. Okay, so here you can see that a number can be have different factorization by using its factors. Okay, so I hope you clear about what is factorization. Now we would reach the topic prime factorization. All of you listen here. We are going to consider a number 48. And you know that this 48 can be factorized in different ways. So I am just writing some of the factorizations of 48. It can be either 2 into 24, or it can be 3 into 16, that also would be 48, or it can be 6 into 8. Okay, so all these are factorizations of 48. Okay, now the first case I'm going to write here. This is the number 48, and that 48 can be written as 2 into 24. Here you know that 2 is a prime number. So this prime number 2 cannot be factorized further. Okay, prime numbers cannot be factorized further. So I am just rounding it because it is a prime number. And you know that this 24 is a composite number which can be factorized further. Okay, so I am just putting this 24 on a rectangle. So a round represents prime numbers and a rectangle represents composite numbers. Okay, so this 48 now would become 2 into 24. Clear? Again this 24, I am going to further factorize this 24. Okay, so that it can be we can write it like 2 into 12. Okay, and you know that 2 is a prime number, so it is just rounded. Now 12 is a composite number, so it can be put on a rectangle. Clear? Again, this 2 cannot be further factorized, but this 12 can be. So I am going to again factorize this 12. And you know that 12 again we can write it as 2 into 6. And obviously 2, since it is a prime number, I just rounded it. And 6, which is a composite number, that is to be put in a rectangle. Again, you can further divide this 6 also. How can you write 6 factorized? It can be factorized as 2 into 3. Okay, 6 can be factorized as 2 into 3. Now, tell me whether 2 is a prime number or composite number. It is a prime, so it can be just rounded. 3 also a prime number. Again, it can also be rounded. Clear? Now, just do the multiplication or the product of all these prime numbers. Okay, let's do it. 2 into 2 into 2 into 2 into finally 3. Can you tell me what would be the answer? It would be 2 into 2. It is 4. 4 into 2. It is 8. 8 into 2. It is 16. 16 into 3. It is 48. So now you got the number 48 as a product of different prime numbers. All these are prime numbers. Clear? So just like this, we can represent any number as a product of different prime numbers, and such a product is called prime factorization. That is what is called prime factorization. So what is actually prime factorization? Prime factorization is the process in which we would express a number as a product of its prime factors, as a product of its prime factors. You can see that this 2 and 3, all of them are factors of this 48, and all of them are prime also. So if we are representing a number in terms of its prime factors, then such a factorization is called prime factorization. And prime factorization can be done just like this method. Okay, and this method is called factor tree method. It is called factor tree method because it's just like the branches of a tree. We are drawing it, and on those branches we can see all the numbers on those branches are factors of the number on the top. Clear? So this is a method called factor tree method, by which we can do prime factorization of any number. Clear? So just like this, let's check some other ways of prime factorization by factor tree method for the same number 48. We started from 2 into 24. We can also do 3 into 16, and we can do the factor tree method to get the prime factorization of 48. Okay, consider the number 48. Now, first of all, we are writing it as 3 into 16. Now you know that 3 is a prime number, so it is rounded, and 16 is a composite number which has to be put in a rectangle. So 48 becomes 3 into 16. Again, this 16 can be factorized. It can be written as 2 into 8. And you know that 2 is a prime, 8 is a composite number. Again, this 8 also can be factorized. It can be factorized as 2 into 4. 2 is a prime number rounded, 4 is a composite number put in rectangle. Again, this composite number 4 is further factorized as 2 into 2, which both are prime. So both are put in circles. Clear? Now you can write the number 48 as a product of all these prime numbers. Then 48 would be equal to 3 into 2 into 2 into 2 into 2. And this prime factorization is the same that we obtained when we started to do like this manner also. And in whatever ways you are doing factorization, if you are considering prime factorization, then our answer would be the same. Okay, which means there would be only one kind of prime factorization for any number. That's why we prefer prime factorization more compared to simply a factorization, because prime factorization is unique. It is possible only in one type for any number. Okay, so now we are going to practice some other methods of prime factorization, because if we are considering smaller numbers, then the factor tree method we can use. But whenever we consider larger numbers which has to be done prime factorization, then our tree would be a very large one, and it would be difficult to factorize in such a method. Okay, so we are going to study another method by which factorization can be done more easily. Okay, and that method is called upside down division method, which is upside down division method. So let's check how using upside down division method factorization can be done. So here is a question for you. Find the prime factorization of 840. You know that 840 is a very large number. So prime factorization of 840 by using factor tree method would be difficult. So we are going to be familiar with another method of prime factorization, which is called upside down division method. Let's check how this can be done using upside down division method. For that, first of all, we need to consider all the prime numbers at the starting. You know that prime numbers start from 2, then it is 3, then it is 5, 7, 11, 13, and so on, etc. like that. Okay, these are the first few prime numbers. You just want to have an idea about this much of prime numbers. Now we are going to consider the number 840. Clear? I am just writing the number 840. Then I need to do two crosses. One like this and one like this. Okay. And now from here onwards, I am going to divide this number 840 by the prime numbers. And for our answer to be correct, we are going to start to divide it by using the smallest prime number, which is the smallest prime number 2. Now check whether 840 is divisible by 2 or not. Yes, 840 is an even number, so obviously it would be divisible by 2. So I am just writing 2 here. Now I am going to divide 840. You know that when we divide 840 by 2, the half of 840 would be here, and half of 840 is 420. Clear? Again I am going to check whether the number 420 is further divisible by 2. You know that 420 again is an even number. So again it is further divisible. Okay, divisible by 2. Clear? Now you know that when 420 is divided by 2, then the answer would be 210. Half of 420. Again you know that 210 is an even number which can be further divisible by 2. Okay. And what would be your answer? When 210 is divided by 2, our answer would be 105. Now, is it possible to further divide the number by 2? No, because 105. It is an odd number which cannot be divided by 2. So, division by the prime number 2 is over now. Now, we want to check whether the next prime number by which this number is divisible or not. You know that the next prime number is 3. And you know that 105 is divisible by 3 because by summing up the digits, you know that 5 plus 0 plus 1, which is 6, and 6 is divisible by 3. Then our whole number also would be, complete number also would be divisible by 3. So I am just putting here 3 because it is divisible by 3, the next prime number. Okay. Now crossing. Now tell me, what would be the answer when 105 is divided by 3? You know that out of this number 10, there are how many 3's? 3 3's are 9. So balance, out of 10, there would be 1 balance. Okay. And that 1 and 5, 15 is to be considered next. And out of 15, how many times 3 occurs? You know that 5 times 3 occurs. So tell me how I just divided 105 by 3. Tell me. I just divided, first of all I just considered 10. And you know that 3 3's are 9. 10 occurs, inside 10 how many times 3 occurs? 3 times. And it would be 9. And what would be the remainder? Out of 10, if we subtract 9, there would be 1 remainder. And that 1 and we consider the 5 together, so that the number would become 15. Out of 15, 3 occurs 5 times. The division is complete. There would not be remainder. Why? Because we already checked whether the number is divisible by 3 or not. It is divisible. So there would not be remainder. Remainder would be 0. Okay. Now further, whether this 35 is divisible by 3 or not. You know that 5 plus 3 is 8. 8 is not divisible by 3. So 35 will not be divisible by 3. Okay. So then we check for the next prime number, which is 5. You know that this 35 is divisible by 5. So you can write 5 here. Now tell me, how many times 5 occurs in 35? You know that it is 7 times. And you finally got a prime number here. Clear? So we would start our upside down division. Actually, usually we write the quotient on the upside, but we are doing that upside to the downside. It is a reverse division. That's why it is called upside down division. And whenever our division ends into a prime number, we can stop this process. And multiplying all those prime numbers starting from here to ending at this prime number last obtained, you can have the prime factorization of 840. So 840 by its prime factorization can be written as 2 into 2 into 2 into, now there are 3, 1 3 into, then 1 5 into 7. This would be the prime factorization of 840. Where do we got these much of prime factors? By doing the upside down division method, in which we need to consider our number and we are going to divide our number with prime numbers, and we start with the smallest prime and we do whatever times it can be divisible by 2, and after that we check for whether it is divisible by 3 or not. If it is possible, then we divide it by 3. If not, then we check to the next prime number, and so on. And our process will, we can stop our process if we got a prime number as the quotient, as here. Clear? Then we just multiply all those prime numbers to write the prime factorization of the given number. I hope you understood how the prime factorization of a number can be done using this method. Now we are going to discuss some more numbers whose prime factorization using the same method. Okay. Now all of you listen here. Here there is a question for you. Read the question. Determine the prime factors of each of the following. So there are some numbers given for you and you should have to find the prime factors or prime factorization of the given numbers. Okay, so let's start from the first number 12. To do the prime factorization for 12, first of all we write 12 like this. Then we are going to do upside down division. For that we can have two crosses like this. And you write the prime numbers we know, 2, 3, 5, 7, 11, etc. like that. So where do we start to divide? We need to start from 2. First of all, we need to check whether it is divisible by 2 or not. You know that 12 is an even number, so we can divide. Sure, we can divide it by 2. So that it would be 2 here. And you know that how many times 2 occurs in 12? It is 6 times. So the quotient is written downside. Okay, not on the upside. We are writing it downside. Now again we are going to check further 2 is, further this number is divisible by 2. You know that 6 is again an even number. So this can be divisible by 2. And you know that how many times 2 occurs in 6? There are 3 times. Shall we want to do further division? No. Why? Because here the quotient now obtained is a prime number. We need to continue our division until we get a prime number there. Clear? Here we obtained the prime number, so we can stop our process. Now how this 12 can be written as a prime factorization? 12 can be written as 2 into finally this prime also 3. 2 into 3, just like this. Clear? I hope you clear. Okay, now we are going to do the next one, which is 136. So let's start 136. We shall write 136 here, then 2 crosses. Then we start from the first prime, which is 2. Obviously 136 is divisible by 2. What is the half of 136? 68. Okay. So I can write here 68. Now again, is it further divisible by 2? Yes. What is again the half of 68? You know that it is 34. Is it further divisible by 2? Yes, of course. So again we can write 2. What is the half of 34? It is 17. It is 17 the half of 34. Now you know that 17 is a prime number. So we can stop our division process here and just write the 136 as a product of these much of prime numbers. So we can write 136 equals 2 into 2 into 2 into 17. Clear? Now we just want to find the prime factorization of 2145. So let's check it out. First of all, we should have to write 2, 1, 4, 5 like this. Then we should have to do 2 crosses like this. Then consider the prime numbers 2, 3, 5, 7, 11, etc. It is the order. We start from 2. You can see that this 2145 is an odd number which cannot be divisible by 2. So we cannot consider 2. Then we check whether it is divisible by 3 or not. Check the divisibility by 3. Sum up all the digits. 2 plus 1, 3. 3 plus 4, 7. 7 plus 5, it is 12. And 12 is divisible by 3. So this number also divisible by 3. So we can start from dividing by 3. Clear? The second prime number. Now, how many out of 21, how many times 3 occurs? You know that out of 21, there are 7 times 3 occurs. Clear? Now, you can see that we are dropping this 4. And you know that how many times 3 occurs in 4? Actually, 1 times. And there would be 1 3s are 3. Then there would be 1 balance. Okay. Out of 4, only 1 times 3 occurs and the balance would be 1. And now you want to consider 1 and 5 as 15. Now tell me how many times 3 occurs in 15? You know that it is 5 times. Clear? Again we want to check whether it is further divisible by 3. For that again you need to find the sum. 7 plus 1 is 8. 8 plus 5 is 13. Which is not divisible by 3. So we cannot do that. So what we can do? We can check the next prime, which is 5. Definitely this number would be divisible by 5 because the last digit is 5 itself. So I am just writing 5 here. Now tell me, out of 7, how many 5s are there? Only 1 5. Okay. Now 1 5 is 5 itself. What would be the remainder here? Here it is 7. So the remainder would be 2. So you can consider that remainder here 2. Now you need to consider the number 21. Okay. Out of 21, how many times 5 occurs? 4 times. 4 5s are 20. Again from this 21, what would be balance? Remainder would be 1. So here it would be 1. And we consider 1 and 5 as 15. And you know that out of 15, there are 3 5s. Clear? Again we want to check this 143 is further divisible by 5. You know that it would not be divisible by 5. So the division by 5 is also over. Now we want to check whether this number is divisible by 7. Okay, now let's check whether this number is divisible by the next prime 7. Okay, and you know that we didn't have any divisibility test for 7. So we just want to do it here. Okay, we are writing 143 here and we are going to divide it by 7, so that it would be 2 times 7 occurs in 14. Clear? And the balance would be 0, and we are dropping this 3 towards here. And you know that out of 3, how many times 7 occurs? It would be 0 times. 3 is a number less than 7. So 0 times 7 occurs. So our division completed. And here there is no 0 as the remainder. Here the remainder is 3 itself. So 7 is not exactly divisible, or 143 is not exactly divisible by 7. Okay, so we cannot consider 7 here. Now we are going to check 11. Okay, now if we check 11, you just write 143 here, then 11. You are already familiar with the divisibility test for 11 also. You can find the sum of the digits which are at the odd and even places. Okay, which are the digits at the odd places? This is odd, this is odd. So what would be the sum? 3 plus 1 is 4. And there is only one digit at the even place, which is 4 itself. So sum of the odd digits is 4, sum of the even digits also is 4. So that their difference would be 0. And if we got the difference as 0, then that number is divisible by 11. Okay. So this 143 satisfy the divisibility by 11. Okay. So we can divide it by 11. And tell me, how many times does 11 occurs? You can see that out of 14, only 1 times 11 occurs. 1 11 is 11 itself. What would be the remainder in 14? It would be 3. So next we would consider 3, which is 33. How many times 11 occurs inside 33? It would be exactly 3 times. Now you can see that 13 is a prime number. So we can just stop our division process here. And you can write the number 2145 equals 3 into 5 into 11 into 13. This is the prime factorization for the given number. I hope you clear about how the prime factorization using upside down division method can be done. Now you would be having some homeworks related with these kind of problems. Okay, all of you should want to do that homeworks on the day of uploading this video itself, and all of you should have to send it to me as a personal message through WhatsApp. Okay, now we can see on our next class. See you. Bye bye.